Walker today. Okay. Right, good evening, ladies and gents. Thanks for being here. Thanks for being on time. Thanks for the quiet as well. I appreciate it. All right. Let's see if we can maintain that during class. Unless, of course, you have questions or I ask you questions and I would like you to answer. Please and thanks. No. We have a few things to draw. All right. Evening, Logan. How you doing? All right. So just Mr. Douglas to come then. All right. Cool. Well, hopefully he comes sooner rather than later. All right, so folks, we are continuing our little exploration of circle geometry or circle theorems, depending on who you ask, right? When we met last on Wednesday, we learned this rule. This rule says that the angle between a tangent and a radius at the point of tangency is 90 degrees. A tangent is a straight line that touches a circle at one point on its circumference. And a radius, as you know, is any straight line in the circle from its center to its circumference. And as we know, it can go in any direction. Once it is bound, once it is from the center to any point on the circumference. All right? So we are going to actually expand on that rule today by looking at where we have two tangents to a circle, and more specifically, two tangents that originate from the same point, all right? So the heading today is two tangents to a circle, two tangents to a circle that originate from a common external point. From a common external point. Right, okay. Fish papa. I don't understand the name, but cool. Karuna is level 17. I am level 1, so I know how to get to the next level. All right. So, let me just tell you how many diagrams on the initial page, right? I have 4 initial diagrams, right? They're all going to be a circle with two tangents and a couple other things, right? So you don't have to, don't draw the circles too big, right? But don't draw them microscopic because we're going to need a little room on the inside, all right? One, two, three, four, five, six, right? That's good. All right. So we have a circle, and like I said, we have two tangents from a common external point. It means that the two tangents start at the same point outside the circle, right? So let's say we have a point here, point here, right? Let's call that point P. And let's say we have a tangent from P right to there, and let's do a green one. Right, so R and B, P, R, and Q. Let's call it R and Q, right? So we're going to call this point of tangency, we're going to call that R, right? And this one down here, we're going to call that Q. And we have a couple of observations. Hey, Christine and Linda, good evening. Giggity. Right, lovely. And our observations are as follows, right? So the length, so when I put these two strokes like this and put the line in between, right? That means magnitude or length of, right? So the length of PR is equal to the length of PQ. Right? So the distance from that common external point P, to each point of tangency, those distances are equal. All right? And that is the note. All right? The distance distance from the common external point right? That common external point being point P, right? To each point of tangent C is equal to each point of tangent C is equal. All right. Ooh, look Mars, look Ryan, hey Ann, C-Chex, Tyrell, and Cookie for vibes. Okay. All right. And oops, yeah, if you want, you could even say I wonder if I could put that in a slightly heavier way, boy. Right. Could say that tangents to a circle from a common external point are equal in length. Right, so that's the rule that we're going to have to cite. Right, so it's a bit to write, so we'll try to figure out a different way to notate it so it's not as cumbersome. All right, so I'm going to actually copy and paste this diagram here. So I'll give you a minute or so to copy whatever you had to copy down before I modify it, right? Copy, paste, right. And this one we'll call item 2. Oops, forgot to put back on the pen, right? So item 2. Right, so the rule we learned last time is that the angle between tangent and radius is 90 degrees. So guess what we're going to put in now? We're going to put in a couple of radii. So O is the center of the circle. So we're going to put a radius from O to R and a radius from O to Q. And we're going to notate that the angle here is 90 degrees at top. Sorry. And the angle down here is also 90 degrees. Okay? Hey Danny, what vibes? Super cat back, boy. What? Good to see you on. Oh, what's going on with this thing, boy? It's not ticking? Okay, well, we'll have to just switch to the other one then. That's fine. I suppose. All right, so check this, right? In the diagram here, what we just saw from the diagram above is that this length here, which is the pink length, PR, and this length here, the green length, PQ, they are both equal, not so? So we're going to put a little stroke there to show that, hey, those two things are equal. And what do we know about all radii in a given circle? In a given circle, all radii are equal in length. So we could put a little double stroke here on OR and a little double stroke here on OQ to indicate that those two lengths are equal, right? So what we see here, hold on, let me see if I could just modify something here real quick, right? Give me 1 sec. Right, I'm trying to decrease the excess of the tangent so we can kind of focus on what I want to talk about here. All right, cool. All right, so check this, right? We're seeing these two tangents to the circle and the two radii that meet each of those tangents at the point, at the circumference, right? So long story short, how many sides are you seeing to that straight-sided figure? 4 sides. What do we call a 4-sided shape? A quadrilateral, all right? So that's our observation, right? Now, again, I just wanted to be mindful about how we go into this. We are looking at the item and we are making observations, things that we already knew but may not necessarily have been pointed out to us before. Okay, all right, so PROQ is a quadrilateral, but it's not cyclic or cyclic. How do we know it's not a cyclic quadrilateral? Correct, it's not inside of the circle, right? A cyclic quadrilateral is a quadrilateral that is circumscribed, as in drawn inside of a circle where all the vertices touch the circumference. So PROQ is a quadrilateral. Right? Not cyclic or cyclic though. And what do we know about the sum of the interior angles of a quadrilateral? Cyclic or otherwise? They add up to 360, right? So we could say therefore, right? So we have, let's put this angle across here as angle P, right? And we'll put the angle at center as angle O. Right, so we'll name the angles after the vertices where they are located. All right, right. So therefore, angle P plus angle R plus angle O plus angle Q, right, is the sum of the 4 interior angles of a quadrilateral, and we said that is equal to what again? 360 degrees. Very good. Okay. Now, what do we know about angle R and angle Q? They are each 90, well, there's not right angle triangles, we have a quadrilateral, yeah, but they are right angles, so that's correct. Hey, Fisher, come back. All right, cool. Right, so we don't know what angle P is right now, right? But we know the angle at R is 90 degrees because it's the angle between a tangent and a radius. Angle O is at the center of the circle. We don't know what its magnitude is, but we know angle Q is also 90 degrees. All right, and the sum of those 4 angles is still 360. Now, when you add 90 and 90, what do you get? 180. So if we just kind of rearrange a little bit and we put the P and the O there, 90 plus 90 is equal to 180. And of course, those sum to the same 360, right? Now, if you consider that P plus O plus 180 is 360, tell me something. If what do I have to add to 180 to get 360? 180. So if I tell you now that P plus O is equal to 180, would you agree? I hear 2 people. What about the rest of the world? Or they hypnotized or what? Yes. Yes? All right, cool. I get 2 more people. Right. So we could say, therefore, right, angle P plus angle O, right, is equal to 180 degrees. What do we call, is a name that we give to 2 angles beginning with S, right? Now when they add to 180. I hear it. Supplementary. When 2 angles, so that was, what rule that was? That was the, what you call it? The opposite angles of a cyclic quadrilateral was supplementary because they added together to give 180. Right, so in this case now, these 2 angles here are supplementary, right? Those 2, right? So now I've never seen this particular rule articulated in the text as part of circle theorem, although I believe it is part of circle theorem because we just deduced it, and if we deduce it, it can be deduced by anybody, right? Especially the well-learned scholars of old, right? So the angle at center right? Which in this case we are notating as O, right? And the angle between the two tangents, yeah,
will be on the quadrilateral as it 56. Is that a rule?
quadrilateral, yeah. For any given quadrilateral, the sum of the interior angles is 360 degrees. That's correct.
You have to write that on right?
We don't write it here. Yeah. If you like proven some rule in a question and you have to make reference to it, then because that was part of how you figured it out, then yeah. Right? Between the tangents, oops. All right, so that one is supplementary. The angle at center and the angle between the two tangents are supplementary. Right, so the angle at center and the angle between the two tangents are supplementary. What does that mean? That they add up to 180. So, I'll give you a minute or so to finish copy that stuff down. I'm just going to copy and paste the diagram again. I'll give you some time to. Sorry. Oh. Hey, Bunny, good evening. How you doing? Good to have you on. Hey, Kezia, or Keziah. Not sure what the wrong name. Oh. Alright, so quick question. Apart from the item in orange, right, which is the angle at center and angle between. You here? Alright, good to have you. Yeah. Right, that thing about the quadrilateral, we knew that already, as in the sum of the angles, the interior angles of a quadrilateral is equal to 360 degrees. All right. Now, hold on. Let me wait till I see some pens down so I can see people could focus on what I'm about to, because what I'm about to do here is adding one thing to it, but it's going to split this shape into two other shapes. And we're going to see some interesting things pop up here. Hey, Lilipad, good evening. How are you doing? Good to have you on. Right, so I think what I'm about to show you here is something that one of you all was actually seeing earlier. At least I'll give it the benefit of the doubt. It says something about 180 degrees, so that will factor into here as follows, right? So this is what I'm going to do here, right? So I'll scroll down a little bit, right? Anybody still copying anything down? We good? Okay. Thanks. Let me just see how I'm looking on the vertical there, boy. Good. All right. I'll have to shrink this because I have one more diagram after. Add water gumball. All right. I am going to draw a line from point R to point Q. When I draw that line, it divides the quadrilateral into two shapes. What are those two shapes? They're each triangles. And more importantly, they're each a specific type of triangle. They're both isosceles triangles, right? the triangle on this side here is isosceles because, because it's constructed with two radii. And as we know, in any given circle, all radii are equal in length. And the triangle on this side here is also isosceles because that was the first observation we made. Right? What was that observation? That that if we have two tangents to a circle that both start at the same point, the distance between that point and each point of tangency is the same. So PR, the pink line, and PQ, the green line, are equal in length. And with the inclusion now of that orange line, that orange chord, right, we have created two sets of isosceles triangles, right? Hey, evening, Rissa, how you doing? Thanks for joining back. All right, so we have a couple of observations here. All right, so again, some simple observations, nothing too fancy or too obscure, right? So triangle ORQ is isosceles, ORQ being the triangle to the left on the inside of the circle. Triangle ORQ is isosceles. Right? And this is because, right, OR is equal to OQ. Right? They are both radii. Right? And we could also say that angle ORQ is equal to OQR. ORQ being the angle up here. Right? This angle here. And OQR being the angle down here. Right? Let me actually put those in a different color. What color I could put them in, boy? I didn't use blue. Let me use blue now. Why not? That's just like a little squiggle, like a dash. You could put an R if you want. Actually, you could put the word R. A-R-E. O-R and OQ are radii in the same circle, right? So these two blue angles are equal. Right, I'll underline them in the blue there. Hope you could see the blue. I don't really want to color them in because that just get messy. Right? Right. And the triangle on the outside is triangle PRQ. Right? Triangle PRQ is also isosceles. Right? And that's because the length of PR is equal to the length of PQ. Right? And then on top of that, we have another pair of angles that are equal. I'm going to put them in purple, right? This angle here, PRQ, and this angle here, PQR. Okay. So angles PRQ and PQR. Oh, thanks to the likes, guys. Heater vibes, I see. What's going on? Are equal, and I'll put that underline in a purple, so we could connect the colors, right? Hey, Ginger, vibes. Right, and we know that these two angles on top here, the blue and the purple, will add up to 90 degrees, and these two angles down here, the corresponding blue and purple, will also add up to 90 degrees. So again, just some observations we're making based on what we could see, right? Hence they're called observations, right? So we could say on the top that hold on, this shouldn't have an, right? ORQ plus PRQ is equal to 90 degrees, right? And then on the bottom, OQR plus PQR is also equal to 90 degrees. So each of those pairs is a pair of complementary angles, right? If supplementary angles add up to 180, complementary add up to 90 degrees. All right. Okay, I have one more diagram here, and then we're going to get into some work. Just give me 1 sec. Let me just see. Okay, yeah, all right. Well, I got how to fit on 2 pages, that's all. All right, so I'll give you a minute or two to finish copying whatever to copy down. Aha. Mel, Julian. Hello, Mel. Hello, me. What vibes? Oh, okay. Hey, good evening, Janaya. How are you? Good to see you on. You missed your accounts. All right. Doing some more circle geometry here today. All right, we're exploring 2 tangents to a circle. All right, so I'm gonna be on the 4th diagram out of the first 2. So maybe what I could do, I could send the first 2 in the chat. I should have done that, you know. Okay, let me start. All right, 1 sec. This is the first 2. Right, and I'll send the second 2 when I finish the 4th diagram here, right? Just me, probably. Right, so in this diagram here, I drew a vertical chord coming from R to Q, right? In this diagram here, I'm going to draw a horizontal line. It's not a chord. A horizontal line from P to O. Now, when I do that, what happens again here? I cut the quadrilateral into 2 triangles. Now, they're not isosceles, right? But they're 2 right angle triangles. And on top of that, there are 2 identical or congruent right angle triangles. How do we know that? Well, if we look at this line here, the pink line and the green line, are those lines not equal? And these 2 lines here are radii, which are also equal. And the angle between those 2 pairs of lines is also equal. All right? And on top of that, the 3rd line in the triangle is another common line shared by both triangles. Right? But all we need to prove congruency is that is these 2 pairs and the angle between. All right? So those are the notes, right? So triangles PRO, sorry, 1 second. PRO and PQO are congruent. All right. So we have that OR, the length of OR is equal to OQ, which are the two radii. Sorry, one sec. Right? We have that the length of PR and PQ are also equal. Right? Two tangents. Now, it's not any two tangents, eh? It's two tangents from the same external point. Right? And the two triangles share a common hypotenuse. Sorry, that wasn't what I wanted to put. An angle PRO and PQO are equal. PQO. Hey, Amelia, how are you doing? Right? Now, we have a couple other things to put here. Right? We could say that these two angles with the orange dots are equal. Right? Which you could see, right? As POR. So we could say additionally, angle POR is equal to angle POQ. And these two purple ones on the outside here. And that's what that is RPO is equal to QPO. Seals, going on seals and sweet keys. Now, I will add an extra note on top of here as well. For this one, each of these angles, each of these two orange angles adds back to the original angle at center. All right? That's equal to a half of ROQ. Right? And each of the purple angles adds back to the angle P, RPQ. Right, let me see. Anything else here? One sec. Right. Right. There was one more observation, but I think I'll hold off on that for now. One, two, three, four, 5, 6, 7, 8, 9, 10. I have 10 people in class. All right, cool. Yo. If this is a part of a question, no, it is just notes. Easy? All right, cool. All right, Google Meet. Just give me a quick GNU chat if you guys are good with the observations that I made. Right, if of course you need me to re-explain any of them or all of them, because, well, I can't do all of them. Yeah. All right, just give me 1 second. I'm going to send a picture in the chat, right? Okay, let me see how I can deal with this easy now. The last part tweaking out a little bit. Alright, no worries. The last part being what the
Last year you call it group because the song is say or half of the group that be correct. So the other one is not more PQ.
yes, sorry, you're correct. RPQ. Sorry, thank you very much. And then QPR. No, hold on. No, it is RPO. So this angle here and this angle here are equal, and they're each half of this whole angle here.
Right.
Make sense now? All right, cool. RPQ, no, RPO, right. RPO and QPO, right. Okay, cool. Right. All right, give me 1 sec. I want to print out the question for you. Is the first question, sure? Well, I have 3 copies, boy. Okay, cool. Well, whatever. Oh, whoa, no. Okay, cool. So yeah, so no. Let me delete that and delete that. Cool. I have 10 copies. 10 copies. 9. Come on, man. All right. I'm gonna hope it went to print. Yeah, it did. Okay, cool. So my phone died. Did I miss a lot? It depends on from where you saw. Who do you go, vibes? I never got back to you, boy. Sorry about that. Things just got real busy, including having a baby. So, yeah. It might take me a little while to get back to you. Sorry about that. Hey, Selena, how you doing? I think I sent 10 to print, but then it went back to 9. So I'm just going to print this one. All right. You can handle that in the meantime. And then just rounds back with the next 2. Yeah, one each. Yeah. Hey guys, the diagram came out bigger than I expected. Yeah, don't worry, Bunny. We're gonna go through some examples on the screen now, so you should be able to, yeah. Yeah, I think I have 2 more there if anybody didn't get. Well, I think, one for you and one for anybody, right. All right, guys, so we're gonna go through a couple examples just to kind of get you in the groove with this particular set of rules, and then I'm gonna kind of let you loose to see what you could come up with. Okay, cool. All right, so let's zoom in first. So, quick question. Does this diagram have 2 tangents to the circle that start at the same point?
Yeah.
Yes. Right? So, we have a tangent from T to A, and we have a tangent from T to B. Right. The 4th question is that. Oh, no. That was the last one. The 4th one was the last one, buddy. Yeah. Right. And what do we know about 2 tangents to a circle that start at the same external point? They are equal in length. So we put a little stroke here, we put a little stroke here. All right, cool. Now, what can we also, not deduce is 0. I'm not looking. What can we also say about OA and OB? They are 2 radii in the same circle, which means what about their lengths? They're the same lengths, they're equal. So let's put a little double stroke there. I'll double stroke there. Okay, cool. Now, there's only one angle here for which we have the magnitude. What angle is that? Angle at T. And what is the value of the angle there? 40 degrees, right. Now, we went through some stuff just now. Let me see if I can disappear a line. If I were to disappear this line here. Oh, hold on, no, I didn't. Let me use a slightly heavier weight on the pen. Right, that's good. All right, what do we know about the angle 40 and the angle at Z, they add up to what? 180 degrees, right? Z is 140, very good, right? And now, if we have Z, we could also find Y, because angle Z and angle Y exist in the supplementaries. Very good, Kozlov, yeah. Angle Z and angle Y exist in the same triangle, not so? What's the sum of the angles in a triangle? 180. So, right? So, if we have this as 140, how would we find angle Y? 180 minus 40 divided by 2, because this angle down here is also going to be equal to Y. What about X? We totally neglected X. We could have found X right away, because what do we know about the orange triangle? All the angles inside add up to? In this triangle here, the sum of the angles is equal to 180. And if you have 40 degrees here, and we know it's an isosceles triangle, we know this angle here is also going to be X. So how would we therefore find the value of angle X? 40 from 180 and then divide by 2. All right, cool. Right, so I want you all to do that. All right, so let's zoom out a little bit. All right, so let me start you off here, right? Because to be fair, this really was an example, right? Okay, so to find angle X, all right? So we know, right? Sorry, just now. That we do 180 minus 40 divided by 2. Right? So we could do a little 1 here. We could do a little 2 down here. Right? So 180 minus 40 is how much? 140. And 140 divided by 2 is how much? 70 degrees. Right, so rule 1 is that, why am I using 180 again? That's because the angles in a triangle sum to 180, right? So, angles in a triangle sum or add up to, yep. 270 for what, boy? For this one here? When you divide 140 by 2? Oh, you keep it. Oh, well, 270 will be 3 right angles. Okay, yeah, that's interesting. Not sure. Yeah, all right. Well, let's see if we can work on that. Ed, do you want to ring? Right. Right. Oh, sorry. And then item 2 was that isosceles base angles of an isosceles are equal, right? So base angles of an isosceles are equal. Right, and then I'll put a 3 here because why is it an isosceles triangle? Because TA is equal to TB, right? Because these are 2 tangents to a circle. Right, starting at T. Right, so we know when two tangents touch the same circle and they both start at the same point, right? The lengths of each tangent are equal. The length of both tangents, the length of both TA equal to TB, right? Okay. Again, yes, there's plenty of writing, but that's the name of the game with circle geometry. All right. Okay, so we found angle X. Let's talk about angle Y. So angle Y. Wait, how are we going to find that 1 second? Oh, well, That one is kind of easy. Angle Y is simply equal to 90 degrees minus X. All right? Which is 90 minus how much? 70, which is 20. Right? We could put a little 4 here. Right? And the 4 through we are applying. How we know that's 90 degrees? Because this whole angle here is the angle between a tangent and a radius. And what did we learn about that angle? It's equal to 90 degrees, right? So angle between tangent and radius is equal to 90 degrees. Sorry, that word came out very jumbled. Hey Jade, evening. And congrats again. I saw your announcement. Hoping all goes well and safe. How you doing? You're most welcome. Alright. Yeah, Gil. I know maths wasn't your favorite subject. I remember that much. Yeah, funny part is sometimes people finish and they come back some years after. Sometimes things make a little more sense. Interestingly enough. All right. All right, cool. Yeah.
Number 3, the word after the.
Sorry, circle. My bad. Yeah, come true. Any color or black specifically? Or? Black. Yeah. All right. Okay. Let's take a look at angle Z now. Right. So Z is also a kind of easy one, right? We know that that's 180 degrees minus 40 degrees, which is equal to 140, right? And we can put a little 5, right? And 5 is angle at center, and angle between tangents, right? So you could put R supplementary, or you could put sum to 180, which is actually simpler to write. Right? So yeah, so in some cases, it's not too cumbersome to write out the rules. Yeah, I did. Thank you, Kezia. I did. I spotted it after. Thank you. I appreciate it. Good looking out. All right. Guys, just give me 1 sec. I'm going to print the next question out for you all to do.
Chris, what was the word after tangent?
Give me 1 second. Right. Good. Right, cool. Sorry, okay, going back now. Right. Angle at center and angle between tangents are supplementary. All right, cool. Okay, so Aisha, D'Angelo, Donovan, Janaya, Javier, and Logan. Just give me a quick G in the chat if you're good with what I have on the screen here. If you need me to re-explain any of them, give me an R and tell me if it's X, Y, or Z, etc., right? One, two, three, four, five, six. Okay, well, that's everybody, boy. Thanks for responding quickly, as a matter of fact. All right. Jared, between question marks. Okay, not sure if it's you. Fun times. All right, yeah, there you go. All right. Yeah, okay, so I've given you guys this one to try. I'll go on to the second page where the question is just now, so those online can see the question. Let's wait and finish copy down. All right, cool. Anybody else? I see Noah still copying some stuff. Oh, no, I did not. Thank you for reminding me. There we go. Oops. Sorry, TikTok.
No, it's fine.
All right, cool.
I will say something. Also, Chris, I have another mini cat chronicle for you.
How many what?
Another mini cat chronicle.
Oh, Lord.
Not a full
Uh-huh.
one. So Jackson thing is like him and Natalie have a little triangle going on.
Oh, Lord.
Yeah, Jack's the outside man. So usually Natalie be working from home, but for the last few
Right.
weeks he's been going to work.
Yeah.
So what Jack's doing now is sitting down by the door. We had to put a box for him because he just sits on the floor waiting by the door until he comes up. But we realized recently when we last time we all Burger King, this cat loves plastic straws.
That's a very odd thing to like, but okay, all right.
Loves plastic straws, so that's what we think. That'll get him to come upstairs and he's eating daddy.
Plastic straws.
So I was sent with a message from him that if you ever have any trash plastic straws in all our pizza, you can just save
Send.
those for us.
Okay. Yeah. I
And
have.
he'll greatly appreciate
Yeah, no
that.
problem. I'll try to remember that. And yeah, if you order, we go through a drive-through or something, and
Yeah, that's really his biggest thing.
right, yeah. So this is a question I have on the screen here, so I'll give it a few minutes to organize. Right, it's basically a carbon copy of the question that's kind of rotated. So you can find stuff in the same order. You can go out of order with different rules. There's no one correct way to do it. But make sure and cite your rules, please and thanks.
And I'm noticing for these ones, the angle on the side of the triangle by the origin, it's always half.
Yep. That's
Is that a rule that we would have gone with already?
That's not right. So you're talking about Q? Like
Yeah.
Q is half of 46, is what you're
Yeah.
saying. Right. So angle between radius and chord. That's an interesting one.
Because how I'm going to find your
Let me see. Hold
I
on.
go for an art first.
Right. So
it's a
140.
dimension,
Right. Right. Yeah. So it has to do with the fact that so because R and in this case T, I guess you could say are supplementary, right? So if you think about it, in each triangle,
You're taking away 180. Yeah.
the sum of the other two equal angles in each of those triangles is equal to the
Outside.
yeah.
Fine.
Yeah, like they say, math is study a pattern. So when
Yeah.
you could spot it, but you have to be able to articulate it. And sometimes the articulations are a bit cumbersome. That's my only problem. You know? Anyway, Jaden, you alright? You knock out? Alright. Okay. Alright guys, I'm gonna just starting here. Alright, if it's still working, that's fine. And I still want you all waiting too long on me. Hey Tyra, thanks for the follow. Appreciate it. Alright, so let's go to angle P. So, alright, so with angle P, we know that TA and TB are two tangents to the same circle starting at the same external point. So we know that TA and TB are equal in length, which means that the triangle TAB is isosceles. Okay, so let's say for P. Right, so for P, so let's actually let's keep it consistent, right? So with P, we could do 180 minus 46, then divided by 2. So that's 134 degrees divided by 2, which is equal to 67 degrees, right? Sorry, that looks like a 6, my bad. Okay, so we could do a little 1 here, we could do a little 2 here. And it's the same setup like last time, right? So that one is that angles in a triangle sum to 180. All right, an angle, and item 2, all right, base angles of an isosceles are equal. And I'll put a little 3 here, and I'll say that the length or magnitude of TA is equal to the length or magnitude of TB. All right. Both tangents start at T. What is all of this? Right, sorry. So that's P. All right. Let's find Q now. So let's do Q in a different color. All right. So to find angle Q. So again, what we could do, if you want, you could take the fact that this angle down here is 90 degrees, right? And this angle across here is also angle P. Right. So to find angle Q, we could do 90 degrees minus angle P, which is 90 minus 67, which is 23 degrees, right? And Mishka reminded me of an observation, right? So what she reminded me of is that the angles on the inside of this triangle are half of this angle here, right? Because if you divide 46 by 2, you're going to get 23. And if you divide this angle in 2, you'll get each of these angles as well. Check it out. All right. All right. So I'm sorry. So this is item 3. No, this is rule 4, sorry, my bad. Item 4, right? Angle between tangent and radius my lord. What your name again, young brother? Yeah. We can't talk about them lyrics on air right now, no? Can't do that. See, I come to class and nobody come. All right, cool. So that's that one. And of course now, to find angle R, right? Let's put a line here first. To find angle R, right? So we could use the fact that it's in a triangle and the sum of the angles in a triangle is 180 degrees, or we could just subtract it from 180, right? And get, 180, 46 from 180, my bad. What? Sorry, who? Fly? 5. Which one is 5? R. As in rule 5? Yeah. So we could do 180 minus 46, and that's 134. And like I was saying, if you double this, right, the angle P, right, if you multiply 67 by 2, you'll get that same 134, right? It's not a coincidence. It's based on the diagram. It's not an observation we made, but I'm not sure how to articulate I wouldn't say it's a rule, but I mean, clearly it's something that happens. So it's something that we could articulate and we could use if we could articulate it. All right. This is rule 5. Right? We could say here that A, T, O, and ATB, my bad, not ATO, ATB and AOB are supplementary. Right. Oh, yes, okay. All right. So Google Meet, I check in with you all first. So Aisha, D'Angelo, Donovan, Janaya, Javi, and Logan. Let's give them a quick genie chat if you're good with this question. Right? If you need me to rework any, I would say give me a R, but I have an angle R. So, but yeah, you could give me a R if you need me to rework anything. All right, cool. Sanjay, we're going on Sanjay. What vibes? All right, in class, people, we okay with number 2 on the screen here? Any questions, anybody, anything? Good? All right, lovely. Okay, going again. Yeah, just give me 1 sec. I'm trying to just clip out that one there. Yeah. Come on, man, Philip. All right, hold on. Take that out. Right, lovely. Just go back up. Not you. This. Go there. Right. No, okay, fine. No, come up. Yep. Beavis. Right, cool. Right, sorry, give me 1 sec. Print. Right, sorry, go ahead. Avi, do you do Google Meet or have a lessons? I do, currently in lessons right now, with people in person and on Google Meet. So if you want to jump in the dance, let me know. Right, but there's a cost attached, of course. You can DM me either on Instagram or TikTok, and we can talk more. We'll be happy to have you if you want to join. Oh, that's it? Print 1?
Yeah.
Yeah, go ahead. Let me see what going on there. So no, not to print this one. To print this one. right. Okay, cool. Right. So I have some more questions coming your way. I'm just gonna zoom in here so you can see it a bit more easily if need be. Now notice here we have a line, a horizontal line cutting that quadrilateral. Uh-huh. Hold on, let's know it. What is going on? There she is, right. I don't understand. Right. Yeah, we're making some circle geometry in maths class there. So the first page today had some nice observations of the rules. We have two tangents to a circle that originate from the same external point to the circle, right? Point P. So PR and PQ are the same length. And you could join these two radii here, creating a quadrilateral. These two are 90 degrees, therefore these have to add up to 180 as well, because it's some of the interior angles of any quadrilateral is 360 degrees. We introduce a chord here, we create an isosceles on this side and that side. And you could also, hey, go down, go down, right. You could also draw a horizontal and create two congruent right angle triangles. All right, so we did a couple of questions so far. There's some kind of carbon copies, so we know on a slightly different one here. All right. Yeah. I'm not going to in this one because I watch need time to. We actually ahead of where I was last year this time. Yeah. Yeah. Right. So that's 90 degrees there, and on this side, so that's 13. So that can be 26. So 180 minus is one, and then 360. Yeah. The only thing I would tell is just don't put the equal sign here, because R isn't equal to this. R is actually equal to this.
Okay.
So
Yeah.
that's why I put my arrows initially now.
Yeah,
And then you
that
can
makes
take like step by step. Yeah. All right. Okay. Nope. Right.
But like you see any vision.
Yeah. We'll see. All right. So Jerry, what you feeling about S boy?
Yes.
Yeah.
I'll start with this.
Oh, all right. No problems. Take your time.
Yeah. Sorry. Okay. So you're on row 13. You hold on to this tip right here. It's gonna be double dots. Because it's not about the sound. So the next thing that I would do is okay, so you have this hold on over here is subtract this one. So I'm gonna subtract 28 from this and then find the next side. Okay, thank you. Yeah, and so that was it's okay because I taught you this like that is actually so disrespectful. Nah, you just clearly never
Am I liking your glasses in the corner there, boy?
That would make me like 30.
I have somebody else own.
Right.
Like, when he's wrong, we know who anymore.
You-
You called me 30.
No, I know.
You called me 30.
Technically, I am
I'm gonna go back to my
I
corner
thought
and
this
cry.
was-
Yeah, whatever. Yeah, sure, you know, it was
Right. Right. So let's get a little going here, right? So let's get some colors going so we could refer to these lines a bit more easily. So let's put a line in pink. Okay, it was supposed to straighten automatically, but I guess it did not want to. Right, so the pink line is what kind of line? That is a radius, and the blue line is a tangent. And what is the rule about the angle between a tangent and a radius? 90 degrees, right? So let's put that first and foremost, right? So we can say that angle S is equal to 90 degrees because angle between tangent and radius is 90 degrees. Angle tangent and radius. Now R is a little more involved, all right? Now we know, let's get a different color, right? Let's put a little point there. So that point is the center of the circle, right? If we were to If we were to complete the little circle here, what is some of the angles at a point in a circle? 360 degrees. So if we could find this angle here, we could then subtract it from 360 to find R. Now that's the angle at the center of the circle. And what do we know about that angle and this angle across here? They are supplementary. They add up to 180. And we also know that this angle here is what? 13 degrees. Right? Or you could even say 13. So this is 90 here as well. Right? So the 13 and this angle here must be 90 as well. Right? Those angles are complementary. I don't know if we made that observation. Right? But there are other observations we could make, right? So to find R, now even if you're not sure about the rules to cite, right? If you're not sure, don't let that hold you back, right? If you could find the angle, find the angle. Because as much as I respect the fact that you need to know the rules, to me, if you show me working, I know which rules to use. And if you show the correct working, I kind of know you're not guessing, all right? But again, you like it to cite your rules, which again, I'm not vexed with, but in some cases, they're very cumbersome and it don't make sense. Right? You can't, I mean, it's unlikely that you'll get this by guessing, right? So R is equal, so let's put 360 minus AOB, right? Angle A, sorry, not AOA. Yeah, sorry. So R, so AOB being from here to here to here. AOB being the orange angle at center, right? And then we could go down here and say, okay, well, AOB is equal to 180 minus, 13 by 2. 13 by 2 is 26. 180 minus 26 is 154. And then 360 minus 154 is 206. Right? Now, you could also use the 13 and the 90 here to find this piece of the angle and then just double it. Right? So we'll excuse ourselves from writing too many rules in this particular one because sometimes the rules just kind of bog us down. All right. Okay. All right. In class, people, we okay with this one? Yeah? All right. Google Meet, give me a quick G if you're good with this item here, please and thanks. All right, that's 2 out of 6. 3. All right, cool. All right, I'm going to just put the other one to print. In the meantime, between time. Hello, good evening. Hello. Who's Aaron? Who's Aaron and why is he calling me now? 31667. Alright guys, so let me zoom in here. So in this particular case, wait, what we gotta find? Oh, sorry, this is a simple one. We just had to find this angle here. Given that this angle here is 135. One 687 10. I'm gonna see who this person was.
It was really shameful.
Cool. Yeah. Oh, sorry, the angle at T. Yeah, sorry guys, it wasn't marked on the question, but you're finding the angle at T, the whole angle.
Number 5, right?
No? Oh, you get 2. Yeah, this is number 5. Number 4 was a very different question.
135 is the answer 4.
Yeah, that's correct. Yeah, this was question 4. So I figure we come to that later. Right? No, we have O. We have O. That's 135. We're looking for the angle at T. No problem. Yeah, A is a right angle. That's correct.
Whole angle. It's
Yeah.
just half.
The whole angle.
Okay.
Correct. Yeah, that's all they had in the question. It's an easy one. So we take it and enjoy it.
Yeah, no, it's just this one. It's just this one. That's really easy. Yeah. Yeah.
All right. So define ATB. Yeah. So this angle here and this angle here are supplementary. So ATB and AOB are supplementary. Right, therefore ATB is equal to 180 minus AOB. 180 minus, sorry, 135, which is equal to 45 degrees. Right, sweet, simple, and straightforward. Yo. Yeah. So they give you the angle of 135, which is at the center. Right? So this whole angle here is 135. See where the endpoints of the arrows are? Just to add extra lines to see who could ignore them. Sometimes they give you lines that have no purpose being there, just to see if you could find what they wanted to find. Not every line has a purpose. Right, so in this question, they wanted to find the following angles. Oh, sure, yeah. Good to go? Alright. Alright. So what I'll do is I'll mark on the diagram what they want you to find. They want you to find X, angle Y, and angle Z. Right, so I'll just zoom in here. All right, those in class, you have a hard copy coming, but they wanted to find those three angles. Now, the 125 angle is the angle at the center, right? Where the arc with the two arrowheads are. The arc with the two arrowheads is, sorry. $125 is at the center. Oh, that's correct.
Yeah, sure.
Oh, thanks, Chandra. Oh, Lord of mercy. We're doing that one. Am I doing that one? I should. Shouldn't I? Let's go. Okay, now so we'll pull it. Yeah.
you could take away, which would be roughly 125 and divide it by this y, because these are both isosceles triangles. This triangle and here are going to be the same. Does that make sense? When you count x and y and add them together, subtract the 180, you get this, which will probably be nice. Yeah.
I reach out to this.
Okay. But you didn't figure it out?
As you? Well, I know who else is coming blasting, but you can check if you want. Take a peep, no? Yo, that might be your pops. Quite interesting. No? Is it a silver pickup truck? Alright, don't worry, it's too dark outside, so I'm asking me to tell too.
It's either silver or black.
Yeah, well, if it's black, then it's probably Pedro, yeah. Okay.
Yeah, no, I think it's probably.
Alright, so I wanna deal with this one so we could wrap up and go home.
Oh.
Yeah, I wanted to do one more, but I think I'll do this on this call it off.
Yeah. Check it out.
Alright guys, let's take a look here and see what we can do. Alright, so let's put this one as X. Alright, so X. So that's the angle here, right? But it's half of the angle. Right. So what do we know about the angle at the center of the circle and the angle? Keep you back on, right? Keep you back on, right? Guys, just give me a little thumbs up in the chat. I know you're still there. Please and thanks. Okay, another one. Right, hold on. And are you hearing me too? Right, cool. Yeah, don't have any other question? Okay, yeah, you just let me know. I'll be back. Okay, cool. Okay. We drop again. What's going on with this thing? Okay, hold on, just now. That stream intact. This stream intact. I know what's going on with this thing. That's the blinking lights. Alright. Well, let me do it fast. Right, so 180 minus 125 is 55. And 55 divided by 2 is 27.5. Cool. And that's because ATO and AOB, ATB and AOB are supplementary. ATB and AOB are supplementary. Yeah. I wanted to do one more, but I figure let me not overdo it. Right. We still there, yeah? Learn how to improve. No, we good. We good. Right. Yeah. Hey, is it Jella or Gala? Right. Now, angle Y. Right. Okay, cool. So, to find angle Y, angle Y there. Right. So, we know that this line here and this line here are equal in length. There are two tangents that start from the same point and touch the same circle. Right. Which means that we have an isosceles triangle. And we know that this angle here is also equal to X. Right? So, we know that this angle down here is also Y because we have an isosceles triangle. So, Y would be equal to 180 minus ATB divided by 2. Alright? Okay, Mariel. See you next time. Alright? So, 180 minus 55. Then divide by 2. So that's 125 divided by 62.5 degrees. right? Which we said was half of this, right? We did say that, okay? And then to find angle Z now, so angle Z exists in a triangle with X and Y, not so? What's the sum of the angles in a triangle? 180 degrees. So to find Z, all we have to do is take 180 and minus X plus Y, not so? So X was what? 27.5. And Y was 62.5, which will give us 90. And 180 minus 90 is 90 degrees. Yeah, go ahead.
Find why I didn't.
Yeah, talk to me. So, what you found the angle on the inside here and subtract from 90?
Yeah, because I realized
Yeah, well, no, that's perfectly fine because the triangle there at AOB is isosceles. So 180 minus 125 is the same 55 divided by 2 is 27.5. And then to find y is 60 minus that, which will give us the same, 90 minus 27.5, which gives us the same 62.5. All right, cool. All right, folks, we're going to put a pin in it there for today. Now, if of course you have any questions, if there's something you didn't understand, I didn't get to ask, please feel free to WhatsApp me or Mishka. Right? Apart from that, I'll see some of y'all on Wednesday. And 1 or 2 of y'all tomorrow for AdMaths. All right, guys. Have a good evening. I'll go on there. Later.